Hi learners, welcome to my YouTube channel. So today we are going to do the part 1 of the basic geometry terms. So now let us see some terms. So all of you know this is very common one, that this is a point. So what is actually a point? Is an exact location in space or any flat surface, and the point has no dimension. So now here, can you see a line with these arrows? So this is a line. Why do we say this one? So line is a collection of points that continues without end in both directions, means we can extend this line till infinity, this also till infinity. So these arrows are shown in line. So now we can see here points. So this is called a line segment. So whenever these are fixed, so line segment is a part of a line which two endpoints, means suppose I say draw a line segment of 5 centimeters. So you know this should be 5 and it should not exceed 5 centimeters. So these 2 points, they are fixed. So this we have to put with the dots. Now in the next one we can see there is a fixed point over here and there is an arrow here. So this is called a ray. So ray starts from one point and extends in one direction forever. Means this, wherever there is an arrow, means this can go till infinity, but here this point is fixed. Now you can see here there are 3 points on the same line. So these are called the collinear points. So collinear points are points that lie on the same line. So they lie on the same line. They are called the collinear points. Now you can see the points, they are not on the same line. So these are called the non-collinear points. So non-collinear points are points that don't lie on the same line. So these are called the intersecting lines. So here this is a point of intersection. So we can say this one, intersecting lines are lines that pass to the same point. This is the same point and they are passing to the same point. They are called the intersecting lines. Now the perpendicular lines. So this, when we draw this one, and this says that this is, even sometimes in some places you won't see this box. So whenever we have like this, means this is called a perpendicular. So perpendicular lines are lines that intersect. This is 90 degree. A plane, this is a plane, is a flat surface that extends endlessly in all directions. So now you can see this is a line. These are the points A and B. In mid of it we have C. So this and this, both the distance is the same. So we can say this is the C is the midpoint of A and B. So midpoint of a segment divides the segment into two segments of equal length. Means these two sides, the segments are equal. Then comes an acute angle. So acute angle is an angle that is less than 90 degrees. So now this is, this is 90 degrees. So inside this it can be this one less than 90 degrees, that is called the acute angle. So this is 45. So this is less than 90 degrees. This is the right angle. Means right angle is an angle that is exactly 90 degrees. And the obtuse one, this is 90. Outside this one, whatever the angle, they are called the obtuse angle. So obtuse angle is an angle that is greater than 90 degrees. That is greater than 90 degrees. Now this is a straight angle. So straight angle means this angle will be 180 degree. So straight angle is an angle that is exactly 180 degree. Now this angle, this is called the outside one, this is called the reflex angle. Means here the reflex angle is an angle that is greater than 180 but it is less than 360. It should always be greater than 180 but it should be less than 360 degree. Then now you can see this one whole thing, this is 360, means this is the full angle. Full angle is an angle that is exactly 360 degree. Now many times there is a confusion between the complementary angles and the supplementary angles. So these all terms you should be aware of this when you are learning geometry. So I have given this all the terms. This is just if those who know, that is a revision for them. So now complementary angles are angles that add up to 90 degrees. Suppose now it can be here, when you add this both, it should be 90. So it can be anyways. Now even it can be now This will be 30 and 60. So both when you add, it should be 90 degree. So these are that add up to 90 degree. So these angles can be anything, but when you add both of them, it should be 90 degree. Same over here, when you add this angle, and this is a separate angle and this is a separate angle. When you add this, suppose let us consider this as 1, this as 2. When you add 1 plus 2, it should be 180 degree. So they are called as supplementary angles. So supplementary angles are angles that add up to 180 degree. This whole part should be 180. Now the adjacent angles. The adjacent angles means now angles with a common side and a common vertex. So this is the vertex of this one here. So they are at the side here. So one is angle 1 and angle 2. They are the adjacent angles. Now the linear pair. So this is angle 1 and this is angle 2. The linear pair means it should be 180 degree. Linear pair of angles are adjacent angles. They are adjacent means at the side, but they form a straight line. And that means the angle 1 plus angle 2, that is 180 degree. This you have to remember in linear pair. Now in this one, whenever there's here, so these and this one, angle 1 is equal to angle 2. They are called the vertically opposite angles. Again here what we can say, angle 3 is equal to angle 4. So angle 1 is angle 2. Angle 3 is equal to angle 4. So vertically opposite angles are angles that have a common vertex. Means this is the vertex which is common and whose arms are formed by the same lines. And vertically opposite angles are equal. So angle 1 is angle 2 and angle 3 is angle 4. Now the transversal line, these are the parallel lines, and this line whichever passes through these two parallel, this is called the transversal. So straight line which cuts two or more straight lines. It can be three also. So it can be two or more straight lines at distinct point is called a transversal line. Now these are the parallel lines, this is a transversal, and you can see inside this one, these are the angles, they are called the interior angles. So we can say 3, 4, 5 and 6 are interior angles. Now again these are the parallel lines, this is a transversal. Outside of one, this part and this part, angle 1, 2 and this 7, 8, they are called the exterior angles. So exterior angles, angle 1, angle 2, angle 7 and angle 8 are the exterior angles. Now the corresponding ones. Now see here, corresponding means now this 1 and 5, then it will be 2 and 6, then 3 and 7 and 4 and 8. They are called the corresponding angles. Then the alternate interior angles means it should be interior but it should be alternate. So how it will be, this is the transversal, so once one of the angle should be here, the second should be here. So can you see here x, we can put here x over here. So 3 is equal to angle 6, angle 3 is equal to angle 6 and angle 4 is equal to angle 5. So they are the alternate interior angles. And alternate exterior angles means now here angle 1 is equal to, you have to see on the other side, angle 8 and angle 2 is equal to angle 7. So these are the alternate exterior angles. So now what we can see here, that angle interior angles means here when you add this one, these two of them on this transversal, they should be 180 degree, and when you add this 4 and plus 6, it should be 180 degrees. So what we can say, interior angles on the same side of transversal, when they are on the same side of the transversal, because this is a transversal, they are on the same side, so it should be, these both should be 180 and these both should be 180. So interior angles are on the same side of transversal, that will be angle 3 plus angle 5 is 180, angle 4 plus angle 6, that is 180. Now this is a triangle, this is 1, 2, 3 we can say. So we know in that this when you add all these three, it should be 180. So we say angle sum property of a triangle. Sum of all angles in a triangle should be 180, means angle 1 plus angle 2 plus angle 3, that should be 180 degree. So the next one, so this is a triangle and this is the extended part of it. So we can say this is the exterior angle property of a triangle. If a side of a triangle is produced, the exterior angle form is equal to this is the exterior angle which is outside the triangle. It should be the sum of these two interior angles. This exterior angle should be the sum of these two interior angles. So something, this will be 30 suppose and this will be 45 For example, so you have to add this both, and that will be the 75 will be the exterior angle. So if a side of a triangle is produced, the exterior angle form is equal to the sum of two interior opposite angles. So angle 4 is equal to angle 1 plus angle 2. So you have to add this both here. So this is important. So now here, if this is the angle, this is the meeting of these two lines. This is called the vertex of it. So we can say the initial point is the vertex of the angle. So this one. So now the next one, let us see the difference between the equilateral triangle, isosceles triangle and the scalene triangle. Equilateral triangle means all the three sides are equal, means three congruent sides. Isosceles triangle means this and this side is equal, so there we have two congruent sides. And the scalene triangle means all these three sides are unequal, so we can say no congruent sides. Hi learners, welcome to my YouTube channel. So today we are going to do the part 2 of basic geometric terms. So first thing, let us see the midpoint formula. So this is x and this is the y axis. So we can take points over here, x1 and y1. So the mid of this one is going to be, this is the point of intersection. So that is going to be a x1, y1. And then we'll take here x2 and this will be y2. So the joining point is B, that will be x2, y2. So when we take this is y1 and this is y2, when we take the midpoint of that, that is going to be y1 plus y2 divided by 2. So this is the midpoint of it. And when we take this x1 and x2, the midpoint of this means always we divide it by 2. So we'll take this x1 plus x2 divided by 2. So this is that. So the formula this will be, the midpoint formula is going to be what? This x1 plus x2 divided by 2. And this is y1 plus y2 divided by 2. So you can just see, this is written in words. So if A, x1, y1 and B are the points in a coordinate plane, then the midpoint of the AB has coordinates. This is the midpoint formula. So now let us see for the distance formula. So here this is a triangle here, this will be A, B. So now if A is x1, y1, B is x2, y2 and this C, let us take this as x2, y1. So when we take this one, so what we can see here, this is x2, y2 and this will x1, y1. So here that will be when we subtract this one, what will happen here, x2 minus x1 and this y1 gets cancelled out here. Now again here what we can see, if we take this 2 and this one, so what remains is x2 and minus x2 gets cancelled and what remains is y2 minus y1. So what if A, x1, y1 and B, x2, y2 are points in a coordinate plane, then the distance between AB is what? That is AB, this distance is root of x2 minus x1 whole bracket square plus y2 minus y1. This you will take the square of this plus this, because you know the Pythagoras theorem, that will be, this is the hypotenuse one. This is suppose the angle, this is going to be the opposite one. And this is the adjacent side. So we have this one adjacent square plus, this means this is also called as the base square, that is the base square plus this is perpendicular, or we can call it as the height, that is the perpendicular side is hypotenuse square. So this is the hypotenuse. So the base square, that is root of, so this AB square, this the hypotenuse square is AC square, because this is the base, and BC square, this is the height. So what we have, AB will be, when we square both sides, what will we get? This will get here as AC square plus BC square. So the AB is, this is what, square of AC plus this is the square of BC. Hope you got this one. Now here the Pythagoras theorem, just a simple Pythagoras theorem. Now this is capital X, Y, Z. So this is capital, so we can put this as Y. This is Z, means we can put this all as Z, and this is X, means opposite of this is X. So this is the base, this is the perpendicular side, and this is the hypotenuse one. So base square plus perpendicular side is equal to hypotenuse square. So we can just put this one because this is the base, that is x square, this is z square, and this is the y square. Now the segment bisectors. So this is the segment. You know, the segment means it is a fixed point. We have seen in the previous part. You can just have a look at it. And then we are going to bisect this segment. This AB is the segment, and we are going to bisect this segment. So now see here, this is the bisector. So here, what will happen here? Whatever the sides here, this will be unequal. So A segment bisector is a segment, ray line of plane that intersects at its midpoint, and CD is the bisector of this CD. This is what this will be extended here. This is the bisector of AB. When we write AB and put a bar over that, that means it says the segment. That is a fixed measurement. So now you can see from here to here, this will be the midpoint of it, and from here to here, this point is going to be the midpoint of it. Now the angle bisector. So now if this is a angle ABC, so this is the bisector, means these both are the equal angles. Whatever the angles are, these both will be equal. So this is the bisector, BD is the bisector. So angle bisector is a ray, this and this ray, that divides an angle into two adjacent angles. Means these are the adjacent ones which are at the side. So we can say ray BD, this is the ray BD, bisects angle, this is the angle which is bisects into two congruent angles. What do you mean congruent means? Equal. Whatever the angle you have, this one, the same angle will be here. So which one will be that? That angle is going to be ABD and angle CBD. So then the median of a triangle. So this is the median drawn. This is a triangle and this is the median drawn. So what again you can see, these both sides are equal. So in triangle ABC, D is the midpoint of this BC. So we can say AD is the median of a triangle. And when you see from here to here also, you can also take this midpoint also. Again, this will be the midpoint of that one. Or we can say this BD is equal to this BC. Both is the same. Exterior angle property. The sum of interior and the corresponding exterior angles are supplementary to each other. So exterior angle, what it is? That is 180 minus the interior angle. So this one, suppose this is there. So this is the exterior angle. It is what you have to do, from 180 you have to subtract the interior angle. Interior angles of a quadrilateral. So this is a quadrilateral, and these whatever the angles are, they are the interior. So what we can do, say here that the sum of measures of interior angles of a quadrilateral is 360. Means 1 plus 2 plus 3 plus 4, that should be 360. So measure angle 1 plus measure angle 2 plus measure angle 3 plus measure angle 4, that is 360. Now this is a parallelogram. So now PQRS. So when we say this line, these both sides are parallel and these both are parallel to each other. So parallelogram is a quadrilateral with both pairs of opposite sides parallel. So what we can say, PQ is parallel to SR and PS is this one parallel to QR. So if a quadrilateral is a parallelogram, that is opposite sides also are congruent. So this side will be congruent to this side, and this side will be congruent to this side. So what we can say, PS is congruent to QR and PQ is congruent to SR. And then again there is one point, if a quadrilateral is parallelogram, that is opposite angles are congruent. So this angle P will be equal to this one, and this S will be equal to Q. So we can say angle P is congruent to angle R and angle Q is congruent to angle S. If a quadrilateral is a parallelogram, that is, then its consecutive angles are supplementary. You know, the supplementary means it should be 180. So now consecutive angles means what you can see here. Now here this is S and this is P. So these both they are the consecutive one. This should be 180. Or if we take this P and we take this Q, that will be 180. If we take this Q and if we take this R, that should be 180. If we take this R and if we take this S, this should be 180. When you add this both, it should be 180. So this is what is written over here. If a quadrilateral is a parallelogram, that is diagonals bisect each other. So these are the diagonals and they bisect each other. This is called the right angle. They bisect each other and this will be 90 degrees. So what we can say, here is M. So we can say PM is congruent to RM. And here when we can see this one, SM is congruent to MP. Now the slope of parallel lines, I can say. This one, that slope is what? Rise over run. This is the rise and this is the run. So here what we can do, the formula for that is y2 minus y1 divided by x2 minus x1. Whenever the slope of parallel lines you have to find out. So m stands for the slope, that is y2 minus y1 divided by x2 minus x1. And whenever you have to find the slope of this perpendicular line, so with the product of slopes. So there will be two here. So m1 stands for the first one, this m2 will be for the second. So that should be minus 1. So m1, m2 is minus 1. So the equation of the line in slope-intercept form. So for this one, whenever there is a slope-intercept form, it should be y is equal to mx plus b. So here m is slope and b is the y-intercept. So y is mx plus b. Then for the point slope form, so y minus y1 is m into x minus x1. And here you have to see the points to find x-intercept. Whenever there are problems based on it to find the x-intercept, there what you have to do, you have to take y as 0 and then you have to solve the equation for x. So the point will be what? Because that is the x-intercept means y is 0. So you know this is x and this is y. So here you should put 0 and here you will get something that will be the x. So you will write it x and 0. And to find out y-intercept, what we do, whenever you have to find out for y-intercept, you have to put x as 0. So this is x and this is y. So here you will put 0 and whatever the point you get, that will be y, that will be 0 and y. So these 2 points we have to remember. So now whenever there is angle, side angle, this is angle, this is side and this is angle. So if angle A is congruent to angle P, so what we can say, this side BC is congruent to side QR, and this one we can say angle C is equal to angle R. So we can say triangle, this one BAC is congruent to PQR because these both are congruent. So this should come in the middle. So PQPR. So angle side, this one side means that is also called as side SAS. So see here, can you see this is angle? This is SAS means this is side angle and this is side. So can you see here? The same over here, side angle side. So what we can say, this AB is congruent to this one side PQ and AC is congruent to side PR and angle A is congruent to angle P. So this is what is written. So we can say triangle ABC is congruent to triangle PPR. Then side. So this is equal to this is equal to this one, and this will be equal to this side. So what we can say, when we say this AB is congruent to PQ, then BC is congruent to QR, and then AC is congruent to PR. So we can say triangle ABC is congruent to triangle PQR. Angle side. So here this is angle, and this is side. Angle and side. So what we can say, angle A is congruent to angle D, angle C is congruent to angle F, and this what we can do here, BC, side BC is congruent to side EF. This is what is written over here. And so we can say triangle ABC is congruent to triangle DEF. Now we have to see this triangle proportionality theorem. So in this one, what we can do here. So now this, whenever we write a line and draw, these are the parallel lines. So if if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides. These two sides, it will divide it proportionally. That means what we can say, that is if MN is parallel to BC, then what we can do here, we can say MN, so that is here, AM divided by this MB is equal to AN divided by this NC. So this is what is there. These are the parallel sides. So this is the triangle proportionality theorem. Then the geometric mean theorem. So here this is a right triangle, and this is also the height, or we also call it as the altitude. So in a right angle, the altitude from the right angle to the hypotenuse. So what is that? divides the hypotenuse into two segments. So now see here, this is 90 means this is going to be the hypotenuse. So it divides the hypotenuse into two segments. So the length of the altitude is the geometric mean of the lengths of the two segments. So what we can say here, that BD, this BD divided by this AD is what? Again this AD divided by this C. So this is that what you have to remember. Now the spatial right triangles. So from these spatial right triangles means right triangles whose angle measures are, which are the spatial ones, 45, 45, 90 or 30, 60, 90 are called spatial right triangles. So here 45, 45, 90 means, now see here, this is 90 means these both here, they are 45. So now in this one, in a 45, 45 triangle, the hypotenuse is root 2 times as long as equal. So hypotenuse is root 2 of length. So suppose now this is x, this is x. So now you see how to do this one. X square means you know the base square plus the perpendicular side is equal to base square plus the perpendicular side is equal to the hypotenuse square. So x square plus x square will be what? We know this is x and this is x because these two are this one. So here this is the hypotenuse square. So 2x square is the hypotenuse square. So x square is, if it goes here, so that is going to be root of 2 into this is the leg of it, means root 2 into leg, you can say, means 2 into this x. So now 30, 60, 90 degree triangle theorem. So now this is 90, this is 30 and this is 60. In a 30, 60, 90 degree, the hypotenuse is, this is the hypotenuse. It is twice as long as the shorter leg, and longer leg is root 3 times. So this is the shorter leg and this is the longer leg. So it is twice as long as the shorter leg, and so shorter leg is x, so this will be 2x, and root 3 times as long as the shorter, this one, shorter leg. This longer leg is, this longer is root 3 times, means root 3x. So hypotenuse is what? 2 shorter leg and the longer leg is root 3 shorter leg. So this you have to remember. So by this, hi learners, welcome to my YouTube channel. So today we are going to do the part 3 of the basic geometry terms. So now let us see for a circle. So if this is the point in the circle, so this is called the center. So now this one is the only the half part which passes, means from the center to this one, is radius. The radius can be also, it can be like this one, but it is the half of the circle. It can be anyways. So this, any line, this one from this half part, that is called the radius. And this from here to here, this is called the diameter. So that, but diameter again should pass to the center of the circle. So it can be like this. Anyways, it can be, that all can be considered as the diameter. But now, can you see this one? This is the chord. So chord doesn't pass. This is the center. Chord can be from here, from here, from here. It doesn't pass to the center. So this is called the chord. So now the other term is the tangent. So tangent is, it is just touching the circle over here. So this is called the tangent. So we can give it any name over here. Then the minor arc. Minor arc means this is the small portion which is being shaded. The measure of a minor arc is defined to be the measure of its central angle. This is the central angle. And the major arc means this is the bigger side. This one is the minor and this is the major one. So measure of this one, major arc, is defined as the difference between 360 and the measure of its associated minor arc. From 360, because this whole angle is 360 and this part is the minor arc. So from 360, if we subtract this one, suppose this is 30 degree. So if we subtract this 30 degree, so that is going to be 330. So this is going to be the, this is called the major arc. Hope you got this, from because this is the full circle. From there one, if you are subtracting the smaller one. So here the example is given here. It can be anything. This can be 30. Just I give you an example. It can be 60. It can be anything. The minor arc. If you subtract it, that is the major arc. So now here, this is a quadrilateral and it is inscribed in a, means it is in a circle. So we say it is inscribed in a circle. So a quadrilateral can be inscribed in a circle when, if and only if its opposite angles are supplementary. These are the opposite angles. So this plus this is going to be 180. Supplementary means 180. This and this, the opposite ones are supplementary. So here PQRS lie on same circle if and only if major angle P plus R, what I said, that is the 180 degree, and major angle Q plus major angle S, that is going to be 180 degree. This is what is written here. So now these are the, if two chords intersect in the interior of a circle, it can be anywhere, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So major angle this one. So this will be half of major angle R plus this one. So major angle and this will be the half part of the major, this arc. This is called, this is the arc SR plus major angle, that will be PQ. So whenever you write here, you put SR and you put like this. This is the arc. So see that is, this is called the arc. So this is major angle 1 is half of major SR, arc SR plus major angle PQ. And major angle 2, this will be, what is that? That will be for QR, the arc QR plus major angle PS. Hope you got this. So major angle 2 is half of major angle QR plus major angle PS. Now see how to find the equation of circles. Now suppose now this is the circle, and the center of the circle, this can be written as H and K, and from here to here this is the radius, and this point, this is XY. So suppose the radius of circle is R and the center is HK, this is H and K. So let XY be any point on the circle. This is the circle, on that one there is a point on the circle. So the distance between XY and XK, so the distance between this and this one is R. So this is R, right? From here to here, this is R. So we can use the distance formula. So what is the distance formula? So now what we can do here, x minus h whole bracket square root of, you have to write, and y minus k plus y minus k whole bracket square. So see here, root of x minus h whole bracket square plus y minus k whole bracket square, that is R. So when you square both sides, what is going to happen here? When you square this as well as this, so the root, for this side the root goes off, and here you get R square. So this is the standard form of it, that is the equation of a circle. So this is very important. You have to use this equation of a circle in many places. So if the center is the origin, then the standard equation is called as, so here if this is 0 and 0, so then what is the formula for that one? Means this here becomes 0 and this also becomes 0. So what will you get here? X minus 0 means that is going to be x square, and y minus 0 means it is going to be y square. So x square plus y square, that is R square. So you have to remember both one. If it is, if the center is the origin means 0 and 0, if the points are 0 and 0. Now what is the formula for the circumference of a circle? Circumference of a circle means, we don't say perimeter of a circle, usually we say the circumference of a circle, that is 2 pi r. So here we can also write this as, sometimes the diameter is been given. So this one, this is the radius of a circle and this is the half part of it. And when we extend this one total, that means that is the diameter. So what we can say, this one diameter is 2 times of radius, isn't it? So here what we can see here 2r. So for that 2r, this pi will be as it is, and this 2r, that is d. So we can say d is the diameter of the circle and r is the radius of the circle. Hope you got this both formulas. Then the arc length. This is the arc length. This is point AB. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So what we can write here? arc length of AB, this one, divided by 2 pi r is equal to measure angle, this arc AB divided by 360. So we can write here arc length of AB, this one. This will go here. So that is going to be what? This whole thing as it is. So into 2 pi r. So this dot says that is multiplication. So now the semicircle. Semicircle means you know the full circle is this one. The half part of that one, it can be like this or it can be like this. Anyways, so you know the the circle, the circumference of a circle, that is 2 pi r. So semicircle means a half part of it. So you are going to write here 1 by 2 into 2 pi r. So now how will you do here? And this is for this one. And length of the 90-degree arc, that is going to be 1/4. So see here, this is 90 degrees, this is the point, and this is 90 degree. Semi means it is going to be this a half part, that is going to be half into 2 pi r, because the whole part is 2 pi r. Semi is going to be half, that will be half into here. But when is the same, this is 1/4. 90 degree means that is going to be 1/4 of this circle. So that we are going to write here 1/4 into 2 pi r. Hope you got this one. So this can be also written here 2 2s are, that will be pi r by 2. So to understand it better, let us skip this 1/4 into 2 pi r, because that is 90 degree. So area of a circle, that is pi r square. Then the sector of a circle. So now see here, the ratio of the area of a sector of a circle to the area of the circle is equal to the ratio of the measure of the intercepted arc to 360 degree. So A by pi r square is equal to measure angle, this one AB, this is the arc AB, divided by 360 degree. So we can also write this one, this will go on this side if we multiply this one. So the area, this one A is going to be, this will be as it is, and this is going to be into pi r square. This will go on this side. So it is going to get multiplied. So this is that is the sector of the circle, the formula for this one. So now you know the perimeter. Perimeter means we can see for perimeter of the square. That is here, this is a square. Perimeter means sum of all sides. So this is S, that is going to be 4S. Then the perimeter of rectangle. So perimeter of rectangle, this is a rectangle. Again, this is both sides are L and L. These are the, either we can say width or we can say breadth, both are the same. So this one, so what will we write here? This, we are going to add all sides. So this will be 2L and this is going to be 2W, that will be 2L plus 2W. And then when this is one term, this is the other term. So when you take 2 common, that is going to be L plus W, that is the width. So this is a formula. And perimeter of a triangle, this is the perimeter, and you know the triangle is, this is A, this is B, this is C. So you are going to add all A plus B plus C. And circumference, we don't say perimeter of circle, but we say circumference of circle, that is 2 pi r. Surface area. Now see, let us see the surface area of right prism. So this will be 2B plus pH here. Surface area of cylinder, that is 2 pi r square plus 2 pi rh. Now surface area of regular pyramid, B plus half PL. Surface area of right cone. So this is going to be pi r square plus pi ri. Surface area of sphere, that is 4 pi r square. So this you have to remember. Now let us see the volume. Volume of cube, that is S cube. Volume of pyramid, that is half into BH. Volume of cone, 1 by 3 pi r square h. Volume of cylinder, pi r square h. See, this is 1 by 3 pi r square h and this is pi r square h. So just see the difference between both of them. Then volume of prism, that is BH. Volume of sphere, that is 4 by 3 pi r cube. Now for the areas, let us see for the area of square means, this is S and S. When we take the area, so we just take these two sides, that is S square. Again, for the rectangle, length, width. So just we take length and this width. So the area of paragon, that is BH, that is breadth into height. Area of triangle, half into BH. So now you know area of triangle. Now this is a rectangle. If we take half of this one, so what is that going to be? This is length and this is the breadth. So what will you write here? So we can write this as So this we can also write this as we consider this one, the half of it if we take, this is the base, we can consider this base, and this is the height of it. So what we can write here, half into, because this is a half part, base into height. So half into base into height. So area of trapezium. Now this is a trapezium. So these are the parallel sides of it. So now this is considered this as B1 and this as B2. And this is going to be the height of it. So now what will be write that? Half into B1 plus B2 multiplied by height. Area of equilateral triangle, root 3 by 4 s square. Area of circle, that is pi r square. Area of sector means measure arc. This is called the arc AB divided by 360 into pi r square. See here, area, you should remember the area means, you know the area formula, that is pi r square, and whenever there's only the length is given, that will be 2 pi r. So here the area is pi r square. So this we have to remember how. So by this one we have completed today's work. Do like and subscribe to my channel so you get the notification of the other parts. Thank you.